Hello, friends. Today I will talk about this beautiful Girih patterns. You can spell it Gyra or Girih in different languages, which means knots, and used in mostly in Islamic architecture for decoration of walls with seemingly repeating or not repeating patterns. There are very different examples of it. Today I want to show you how to create them from polygons and polygonal stars, which are knottingly or greekly going into each other. So by starting, we have a very simple formula, which is the formula of the circle actually. In this formula, I will make a little bit more space. In this formula, we have this our typical sinus and cosinus patterns, which are combined with spline factor, which is the number of the each point in a spline in Blender. I have here one curve line. The original geometry I don't use. It's here. I have one curve line which is resampled by as many points as you want to make it look like a circle, and then the positions are set. The x and y positions are set, and I have here some just a note to make the lines thicker and black. Here on the second example, I don't have so many points. So because like if you reduce the points, eventually you will reach the triangle. Or in between there are all these polygonal shapes. But if you have as many points as it makes the eye to seem it as a circle, then you will get the impression of a circle. But basically, it's a very high-end polygon. In another example here, I have just like five cones, five edges. I get them. Let's make here more space. I connected it here. I have the count of the edges, which I use to resample, but I take one less of it because the here happens a circle and it comes back to the same point, and the number of these points or the array must be one more in order to complete the turn of this polygon. So I have here a pentagon, hexagon, and then an octagon and septagon, and you can really use just this simple pattern, simple geometry node setup to create polygons. If you go one step further, if you start to play a little bit and change the sinus and cosinus multiplications, I have here a three-dimensional example even, where I used also play with Z coordination. So you can really have very fantastic wave shapes. But you can really definitely see here how the wave shapes are connected to polygons just by changing a little bit, just by a multiplication of before the sinus and cosinus value, we will get the relatives of the circle, which is very connected to sinus and cosinus functions. We have these wave functions, which are really amazing to play with. I have here another example. If you will take one of them, we will have just like x and y coordinates, just to stay in the two-dimensional space. But if we have a really good method to add them together, we end up in the knots, in the Girih patterns. So we simply add two functions, two circles, which I have grouped here, which are basically what I had before, multiplying this sinus and cosinus functions and combining them and scaling them a little bit in order to reach one circle. And if I go out and add these two circles together to get this position, I have these nice circles. I have to here to mention that what inspired me to do this tutorial. This is Erindale's really fantastic work, where he used them in spirographs and circles to create these wonderful patterns. But this inspired me to go back, and as I started to play and do this tutorial, I got really inspired to do these really nice geometrical Girih shapes. So I want to thank you to him, and I will of course send a link in the description to his tutorial, which is like he's a master of nodes. So I learned a lot from him. So you should also go and follow and check his tutorials. Anyway, here I have some more nodes. So if you start to play with them and come in a certain point, if you have here, I have one where I have like 6 turns. Of course, these are like 5, but as I said, there is you had to add one more. If you don't complete the turn, you will see that you have by 5 you have this 4 turns, which is like just one below. If you are somewhere in between, you see that this, check this end, it looks, and until the next number, it's by 8, it finally reaches. But before, it makes like this little spiral, this circle in circle, where our additions of our circles comes. It makes the circle in circle in order to reach the starting point. So this is how these wonderful Girihs are mathematically built, by adding 2 circles as vectors, just simply these circles which we created just before, and that's it actually. You can see that a nice example here, just like by making a star. The circle here, you can see this is the circle which you see that this just check this end point of it. If it turns, this tries to reach it, and just like here somewhere reaches it completely to make a circle, because the size of the turns makes it. But like if I stay by 5 and then let's go back, I think it was by 6 minus 1, it makes this nice pentagon. Yes, this pentagonal shape, or pentagram. Of course, this is a pentagram, and if you combine one pentagram with a pentagon, you get this very basic of these Girih shapes. Continuing to play with these numbers, you can reach really amazing symmetrical patterns. So where you have like different combinations of them, of the patterns. But what I did here is like just like playing and adding multiple of the circles, and adding another one. I have here like one orange and one red, one yellow and one orangely red. So if I will take this off, you will see this is the red one, and here if I add the yellows, then they come, and for both one, you can have like different combinations, different scales. This is here my scale, and different number of turns of these particular shapes. Just playing these are all just this circular pattern, which is just like scaled, and having just like this very little really nice combination of sinus and cosinus function. And then what I did is, like you see, like there you can really create these nice patterns. And what I really then did is just took 3 of them, and having them, you can just really combine different numbers of inside shapes. I have here like 25 or 5, which makes like this 4. Again, you need another circle to reach the first circle, and 3 of them which you can really combine in different numbers. I have here like one hexagonal shape, one quadratic shape with this really nice arrow shapes, and which are created by again by these turns. And because here I again like these two circles which are added, again the same, really same story. The another one is just like to make this corner shapes, outline shapes. Okay, so you can play with them. You can have a really free one to have like different numbers of them. You have to, of course, take care that you have like integers here. Else you will get this between shapes which are not fulfilled, not full shapes. Just you have to, in turns, you have always have to put integer numbers or whole numbers. And then you can have, if you have like a certain number of them, just check here's a very simple pentagonal shape. And then you can start to put them on a ground and tile them on your own. So you have then here, I have here like 3 different shapes. You can see them by rotation. This is like 0 rotation. Then I have like minus 108. And the other one is here, I think this word here, plus 108. So 108 grades is for pentagons or pentagrams, important that they have like this inside angle of 108. And if you order them in according to this minus 108, then you will get this kind of empty spaces in between the grids, or Girihs, or Girihs and in English pronunciation. Or if you make them plus, like starting with 1, but then the others like 2 are minus 108, and then 3 are plus 108, then you get pentagrammatic shapes in between these pentagons. And most of this architecture, a lot of architectural shapes, they use this kind of orderings in order to get even more complex shapes. So I will upload this file, and of course I will link the tutorial of Erindale to this. And I hope you will get like really nice results, experimental results. Feel free to share them with me, or feel free to comment if you have questions, if you want to ask for other functions. Maybe in the future I can make one where that we can parametrically order this shapes. This doesn't have to be so complex, because like they have like really routine rotational symmetries. So we will see how it takes from here now. Thank you for watching, and enjoy playing with Girih tiles.